Hey guys, today we're going to be doing a mass calculation to take a look at, in theory, how much product that we can make from a decomposition reaction. And the product that we're looking to make is copper 2 oxide. And what we're going to do is we're going to take this chemical here, and it's called copper 2 carbonate basic. Now in this formula here, there is an OH group. So don't let that fool you, but what ends up happening is this compound here, it will decompose into carbon dioxide, water, and copper 2 oxide. The carbon dioxide and the water, they are going to dissipate because they are gases, and what we're going to be left with is just the solid product, copper 2 oxide, in the end. What we want to do is we want to figure out, in theory, how much copper 2 oxide we should be making, and then we're going to weigh what we actually get, so our experimental value, so that we can calculate our percent yield. Let's get started. What we first need to do is to take the mass of an empty evaporating dish. 48.11 grams. Now I want to get 1 gram of our copper 2 carbonate. I'm going to put a piece of weighing paper. I'm going to re-zero, and then I'm going to measure out 1 gram. Next, I'm going to transfer the copper 2 carbonate and put that into our evaporating dish. There we go. And then I'm going to place that on top of a clay triangle that is fixed to a ring clamp on a retort stand with a Bunsen burner. Then we're going to turn on the gas, and we are going to light our Bunsen burner. And we're going to heat that for several minutes. We can see that some of that copper 2 carbonate is starting to turn into copper 2 oxide, which is apparent with that black material. We're going to keep heating until all of that green looks like it's been converted. Now the carbon dioxide that is being created and the water is also created is a gas. So water vapor and carbon dioxide are escaping right now. Being careful to heat that gently. Okay, now that we've heated that for several minutes, I'm going to turn the gas off. We're going to remove the evaporating dish, and we're just going to let it cool on the lab bench. Now that we've let the evaporating dish cool for a significant amount of time, we will then weigh it. If we didn't, then it would cause the balance to fluctuate a little bit, so we want our dish to be cool. And we see that the mass is 48.81. In order to determine the mass of just the copper 2 oxide, you would need to subtract it from the empty container.